Good afternoon, everyone. It's really nice to see you all here today, and I guess that most of us have already left our parental home and moved to a new city or a new country for the most adventurous among us. When we do head back home, however, for the Christmas holidays, for Easter, or for birthdays, some of us will find our rooms in the exact same condition as when we left them, testament to those embarrassing teenage years, while others will walk into a new library, a study, a fitness room, or an arts and crafts lab. If you were to fast forward to 2020, say, the wannabe hobbyist among your families, your mother or your father, may decide to turn your room into a 3D printing lab, an Aladdin's cave waiting to be filled up with shiny baubles and treasures. Has your bicycle chain left you in a bit of a bind, and the shop just happens to be closed of a Sunday? Get Dad to print you a new one. Has your younger sibling just broken your favourite mug from your Amsterdam trip? No sweat, Mum's right on it. Have you gone out for a cheeky cider, only to realise you've misplaced the house keys? No need to tell your parents, simply print yourself a new set. Now, while all of these ideas may sound a bit far-fetched, there's no doubt about it. 3D printing will be part of our lives in the future, if not in our own homes, then as a source of countless products or even organs. However, let's take one step at a time, shall we, and see what 3D printing is all about and how it came to be. 3D printers have been around for almost 3 decades, which is quite an amazing fact when you think about it. However, they're only just starting to filter in the public arena. Typically, you would take data online from the cloud, and this data would represent a geometric representation of whatever you want to print. You would then copy that data into your 3D printer and then print the object layer by layer. However, you may ask yourself, if these machines have been around for almost 30 years, why do we know about them? Typically, they've been too inefficient, expensive, inaccessible, and not fast enough. But today, they are a part of our life, and many barriers, like in other industries, are breaking down. That means that even if you guys won't be able to access one of these machines this precise moment, you will in a couple of years. This will change and disrupt the landscape of manufacturing and most certainly our lives, our businesses, and the lives of our children. So what is 3D printing? 3D printing, or as it's also called additive manufacturing, is a process of making 3-dimensional solid objects from a digital file. You speak of additive manufacturing because you add successive layers. So instead of cutting or drilling objects, as a conventional factory does, by removing materials and arriving to the required shape, a 3D printer starts with nothing and adds stuff to it. So it all starts with making a virtual design of the object you want to print. This virtual design is contained in a CAD, a computer-aided design file. You would then insert it into a computer, copy it into the 3D printer, and then, hey presto, print whatever you want. However, not all 3D printers use the same technology. There are several ways to print, and all these are based on additive technology. One such method is the fused deposition modeling, also called FDM. So the FDM technology works by using a plastic filament and then supplying this filament through a specific nozzle in the printer. It would then start layering different parts of the object in question on a platform, and then slowly build up from there. However, the most common technology is digital light synthesis, and it overcomes 2 common problems in 3D printing. First, it is up to 100 times faster than FDM. Second, the baking process that you would use when you have the 3D object to ensure that everything sets, knits the layers together more effectively, making for a stronger product and also one that has smooth surfaces, which reduces the need for additional processing. So digital light synthesis is a competitive method when compared to injection molding, a mass production process which has been used in factories for nearly 150 years. So injection molding works by forcing molten plastic into a mold. Once the plastic has solidified, this mold opens up and it ejects the part. So injection molding is fast and extremely accurate, but making the molds and setting up the production line is slow and incredibly expensive. So it is only efficient when you actually make thousands of identical things. The usual economies of scale, however, barely apply to 3D printing. Their easy-to-change software means they can turn out one-off items with the same equipment and materials needed to make thousands. While for regular processing plants, you would have to bring in new machines when wanting to tweak prototypes, with 3D printing, all the tweaking happens online on the cloud. So as you can understand, this will change the whole nature of manufacturing. So instead of having these vast warehouses full of machines, you just do everything online. One of the earliest adopters of additive manufacturing was the medical industry, for a very good reason. As you can see, everybody here is different, and so we all need different organs or prosthetics. As a result, millions of individually sculpted dental implants or hearing aids are now printed. And the same applies to a growing number of other devices. Now, the main aim here, however, for the future is trying to print living tissue for transplants. Though this idea is still largely experimental, several groups of researchers are already using so-called bioprinters. Now, bioprinters means that you would take a regular printer and build skin, cartilage, and other tissues. So in the beginning, this might mean printing said skin or cartilage, which are relatively simple structures, and they are more straightforward to grow outside the body. Eventually, however, these pioneers in the industry want to create more complex organs, such as hearts and livers. These could then be used in human transplants. Scientists working at the Wake Forest Institute, for example, have been printing ears, bones, and muscles in exactly this way for over a good 5 or 6 years, and they have implanted them successfully into animals. Now, the crucial part, just like any other regular organ transplant, is ensuring that printed tissue survives, and it then integrates with the recipient when transplanted. Some types of tissue are easy to grow outside the body, as I've already told you. However, there are others that need blood and oxygen to grow. Take hearts, for example, livers, and the pancreas. They do require a blood supply to grow beyond their cells. What is missing, however, in bioprinting is the most important ingredient for all printers, regardless if they are 3D printers, regular printers, or these new printers on the market, and that is ink. You can't print anything if you don't have ink. And so Mr. Eric Gattenholm, a biotechnology entrepreneur from Sweden, decided to establish CellLink and create a type of bioink to ensure that doctors and researchers can indeed start printing organs such as hearts and livers. CellLink has created a specific type of ink which consists of a biodegradable material containing wood fibers. What the researchers do is they mix their own cells into the ink and then insert the ink cartridge into the printer and then start printing. In addition to making bioink, however, CellLink has also launched its own range of printers. Now, these are sold at a discount to universities in return for research feedback. And this is quite important this is quite an important element to bear in mind, because what you should all know is that one of the biggest hurdles in 3D bioprinting was exactly the same challenge that was experienced by regular printers at the start: their exorbitant costs. Indeed, some of the most expensive models back in the day could be purchased for as little as £150,000. So trying to reduce costs is one of the main concerns for the scientists involved in the research. And why is bioprinting lungs and hearts and other organs so important? Well, the thing is, if we consider the UK, for example, not only the UK but also the whole world, there is a global shortage of organs available for life-saving transplants. Going back to the UK, you can now expect to wait an average of 944 days. That's more than 2.5 years for a kidney transplant on the NHS. And there's a similar shortage of liver, lungs, and other organs. Lack of transplant tissues is estimated to be the leading cause of death in America, for example. To be more precise, around 900,000 deaths a year, or around 1/3 of all deaths in America. And all these could be prevented or delayed by organ or engineered tissue transplants. Therefore, the demand is endless. So estimates for a date when organ bioprinting will be viable vary wildly. One team claims that we will have bioprint hearts within 6 years. However, no one knows for certain when these techniques will be approved, and they will be approved as safe by the relevant authorities in the States and in Europe. We won't know if we will move on to human transplants in the near future. However, the sheer number of research scientists working in the 3D bioprinting field, coupled with developments in an industry that is predicted to be worth more than $1.3 billion by 2021, means that we can be sure that it isn't too far away. Thank you.